Hi, I'm Fran. This is our 3-axis magnetic field sensor. The 3-axis magnetic field sensor, and by the way, it doesn't come with the orange arrows, I just put those on for this video, measures the magnetic field in 3 dimensions, X, Y, and Z, and it does this at 2 different magnitudes of magnetic field. So I've placed these arrows at the location of the chip that measures at plus or minus 5 millitesla. There's a second chip that's located 10.5 millimeters from the end, so right about there, that measures plus or minus 130 millitesla. So use the plus or minus 5 millitesla setting for lower magnitude magnetic fields, such as the magnetic field of the Earth or of a solenoid. Use the higher channels, the plus or minus 130 millitesla channels, if you're measuring magnetic fields of permanent magnets, especially neodymium magnets and strong cow magnets. I've put these arrows on the sensor just so that we can see the directions. The magnetic field sensor actually comes without it, so I'm going to use this one for actually taking some measurements. And we're going to use this in a moment, but I'd like to first do an experiment with my slinky. The experiment is, we'd like to measure the magnetic field inside the slinky when there's a current going through it. And so this will help us take a look at the direction of that magnetic field. In order to use the sensor, I'm going to turn it on by pressing the button. And once I've pressed the button, the red LED will flash. In graphical analysis, I'll choose Sensor Data Collection, and then I'm going to look for the ID number that's on the back of the sensor. This one ends in 0U0, so that's the one that came out right here on the top of my list, so I'll connect to it. Once the sensor connects, the green light will begin to flash. Now, since this is the 3-axis magnetic field sensor, I'd like to turn on 3 axes of measurement. It turns on with just the X direction as the default. So I'm going to go to my sensor channels menu here and activate the Y magnetic field and the Z magnetic field. Now I have a graph that has all 3 magnetic fields on the vertical axis. However, to start, I'd just like to take a look at what the readings are. So I'm going to change to the view of just the meters. So here's my measurements. If I put this so that it's at this location, I'm going to get a positive value because the magnetic field is lined up with the X direction. All right, and my Y and Z are close to 0. If I move this around this way, now the Y direction is going to get the positive value, and my X and Z are close to 0. So you see how this works. I'm going to put this in my slinky. And if I want to measure just the magnetic field of the slinky and not the magnetic field of the Earth or this bar magnet, then the first thing I need to do is 0 all 3 channels of the sensor. And then in order to get a magnetic field for the slinky, I need to turn on my current. So I've got a current of about 3 amps going through the slinky. It's perfectly safe, not going to burn me, not going to shock me. And right now I've got my sensor with the X direction pointed that way, the Z direction pointed up, and the Y direction pointed in that direction. So what do I see in my meter readings? I see that X and Z are very close to 0, but the Y direction is giving a negative value. So if that's my Y direction, and I'm getting a negative value, that means that the field direction is actually in that direction to the left. I can check this. I'm going to rotate the sensor so that my Z direction is now pointing to the left. And when I do that, I get a positive value for the Z measurement, and I'm close to 0 for my X and Y measurements. So this is an excellent tool for exploring magnetic fields in whatever direction or shape those magnetic fields may be in. So I'd like to explore a little more with my cow magnet, and I want to use the directionality of the sensor to make a prediction. So if I'm going to take this sensor and move it just alongside the magnet, what would I expect the readings to be? So I would expect that over here at this end, sort of in this area of the field, that I'm going to have some positive X direction and some negative Y direction, because the angle of the field is going to be, at some angle that's not, this direction or that direction. And then if I go kind of in the middle, I'm going to expect to have pretty much no Y direction field, but I'm going to have some negative X direction field. And then if I come over to this edge, this corner of the field, I'm going to have some positive X direction and some positive Y direction. And if I think about the Z direction, if I, you could imagine it if I could take this and sort of 3D rotate it around the axis of the magnet, and could look at, well, how much of it is pointing in the Z direction. I think we'd find that no matter where I put the sensor is not going to be very much. So let's take a look at what the actual result is. I'm going to change my view back to a graph, and while I could do this by going centimeter by centimeter with a ruler, I'm just going to do a time-based experiment because it's quicker, and I'm just going to gradually move my sensor across the paper near the magnet. So I'm going to hit collect. And there we go. So there's 3 traces, 1 for each channel. As you can see, one of the traces is positive and then negative and then positive. Another one is negative and then positive. And another one stays pretty close to the central axis. So if our predictions were correct, then that central axis hugging one, the one that's not getting very large measurements, that's going to be the Z measurement. The measurement that goes from positive to negative to positive is going to be our X measurement, okay, the one that's measuring in this direction. And the one that goes from negative to positive with 0 in the middle is going to be our Y direction measurement, because that's where we were expecting a little bit of this way, and then nothing in the perpendicular to the magnet direction, and then a little bit in that way, the positive Y direction. So let's take a look, and we can see that the X magnetic field is indeed that shape with the dark blue that goes to positive to negative to positive. The Y magnetic field is the sort of greenish color that goes to negative to positive, hitting 0 in the middle. And the Z magnetic field in light blue is the color that stays very close to 0 magnetic field. I'm sure there's many more experiments that you can think up that use the 3-axis magnetic field sensor. And we also have a number of experiments in our lab manuals. For more information, please see our website.